Okay, vectors in 3D. We've just seen how to express vectors in 2 dimensions using magnitude and angle, using the component notation, and using unit vector. We can do the exact same thing in 3 dimensions. So instead of having A is equal to AXI plus AYJ, we are going to add another term for the Z component, AZK. So the convention is to use X, Y, Z coming towards you, I along the X, J along the Y, and K towards you. We will see the choice of IJK when we do the cross product. Okay, so the definition for finding the magnitude of any angle in 3 dimensions is the exact same formula that we can extend in 3D. If you're looking for the magnitude of u, you just take all the components, you square them, you add up the whole thing, and then you take the square root. You can see that easily if you break up this vector u into this temporary vector, and then you break it again into 2 components. Now for the angle, that's going to be a little bit different. In 2D we only have one angle, while in 3D obviously we have 3. One angle is going to be the angle between your vector and the x component. Let's call it theta x. The other angle will be the angle between your vector and the j component, theta y. And the third vector will be the angle between your vector and the z component, theta z. The way they're being defined is very similar to what we've seen before. It's using the magnitude times the cosine of each angle. So in the x direction, ux is magnitude of u times cosine theta x. Uy is going to be magnitude of u times cosine theta y. And uz, magnitude of u times cosine theta z. Now we can check that this is correct. Since we know this relationship, we can square every component, ux, uy, uz, add them up, take the square root, and we better get u. So if we do this, ux squared is u squared cosine squared theta x. Then we're gonna add the square of the second term, u squared cosine squared theta y, plus u squared cosine squared theta z. This should give us u. We can obviously take out u squared, take it out of the square root, so you end up with u times the square root of cosine squared theta x plus cosine squared theta y plus cosine squared theta z is equal to u. And if you divide both sides by u, which you can do because u is positive, you end up with cosine squared theta x plus cosine squared theta y plus cosine squared theta z after you squared both sides. This is equal to 1. This is similar to the analogy that you should know in 2D. Sine squared theta plus cosine squared theta is equal to 1. Same thing. It's just extended in 3 dimensions.